So let's start today's session. I think the screen is visible. Okay. So today we will talk about is assignment 11, week 11. Am I audible, right?
Yes, ma'am.
Okay, fine. So today we will talk about assignment 11, week 11. And let's start. Actually today there will be a little bit more questions. So it will take a little bit more time, but maybe obviously it will be covered up within 2 hours. That is the thing. Okay, one more thing. In the last class, we were talking about assignment 9, question number 6 this year, right? So there was a problem you people told. So I was just informing that one to Professor Thomas, and he said that right now he is busy, but obviously he will see that question, and after that he will let me know what is the thing. Obviously it's the wrong answer and what will be the correct answer, whatever the thing will be there, he will get back to me. But obviously right now he is busy, so that's why he is not going to give the proper answer right now. Okay. But maybe obviously no problem, it will be, I mean, if the marks is deducted also, and it will be retrieved, no problem. Okay, so in that question, sorry, week 11, assignment 11, basically what I will do, I will just add some questions, whatever it was previous year, I mean previous year question papers, as well as I will add some new questions, like maybe it is obviously related to the assignment, I mean week 11. So that's why the length will be a little bit big for this class, and but it will be a little bit funny and enjoyable to see these things. Okay, so first question is, which of the following statements is or are correct? And there are four options. Photon can take part in electromagnetic interaction, photon can take part in weak interaction, photon can directly interact with gluons, photon can directly interact with quarks. Okay, so let me clear, obviously all of you know these things, but still let me clear some portions. Like EM interaction is mediated by photon, as we all know that one, right? Photon. Then weak interaction is mediated by W plus W minus Z0. And strong interaction is mediated by gluon. Okay. So these three we all know. So first of all, whatever the first question was there, photon can take part in electromagnetic interaction. That is absolutely correct, because otherwise electromagnetic interaction, the main mediator for the electromagnetic interaction is photon. So obviously photon can take part in electromagnetic interaction. There is no question on that. Okay. Now coming to option number B, photon can take part in weak interaction. Now, as I already told, weak interaction mediators are W plus W minus and Z0. But it is not the only constraint that only these three bosons can participate in weak interaction. Weak interaction, I mean, the particles which can take part in weak interaction has the criteria that these particles should have the weak charge. So what is weak charge? That we will talk a little bit later. But the main thing is that if one particle wants to take part in weak interaction, they should have weak charge. But the thing is, photons do not have any weak charge. So it cannot take part in weak interaction. I will take what is weak interaction, weak charge. Obviously, maybe you all know these things, but still I will tell what is weak charge. But still, for this question, as far I have told that photon does not have any weak charge, so that's why photon cannot take part in weak interaction. So it's fine that photon cannot take part in weak interaction. Now photon can directly interact with gluons. Okay, so the main thing is that to participate in any interaction, any specific type of interaction, the first criteria is they should non-zero charge of this specific interaction. Means what? First of all, I want to tell that for EM, gamma, for weak, W plus, W minus Z0, and for strong, gluon. So these particles are the mediators of these three interactions. So we are not talking about these three right now. Obviously these three have, like, for gluon has color charge. This has weak charge. This is EM interaction, but obviously it is not, it is a neutral particle, so we can't say that it has the electric charge as the electromagnetic charge should be. But as the gamma, the photon is the mediator of the electromagnetic interaction, so gamma can take part in electromagnetic interaction. But other than these particles, if anyone wants to take part in that specific interaction, then they have to have a non-zero charge of this specific interaction. Now let me tell here, photon can directly interact with gluons. The main thing is with gamma and gluon is like, gluon has color charge. It does not have EM charge. And what about this? It has EM interaction, but it does not have color charge. Right? So photon does not have color charge, where gluon does not have electromagnetic charge. So what will be the consequence of that? The consequence will be photon and gluon cannot directly interact with each other. Why the direct term is there? Obviously they can interact indirectly through a loop level, but for the tree level calculation, as a direct interaction, there should not be possible the interaction between photon and gluon, because photon does not have color charge and gluon does not have electromagnetic charge. Photon will interact only with this particle which has electromagnetic charge, and gluon will interact with this particle which has color charge. But photon and gluon are totally complement to each other, so that's why it will not directly interact with each other. So that is not gonna happen. Now come to fourth option. Photon can directly interact with quarks. Now, as I told, photon is the mediator for EM interaction. Now, interaction. Any particle other than photon who wants to participate in EM interaction should have electromagnetic charge. Now, what about quark? Quark has electromagnetic charge, obviously, because let's say U, P, T, then C, S, B, all have the Q, electromagnetic charge, right? Like U has 2/3 E. Whatever the value is there, that we are not going to see right now, but the value is non-zero. So that means quark and photon can directly interact, because quark has electromagnetic charge and photon is the mediator of electromagnetic interaction. So that these two can directly interact. Okay, so photon can directly interact with quarks. So now the first as well as fourth option are the correct one. Now photon can take part in weak interaction? No, because photon does not have weak charge, as I already told. We will tell what is weak charge, that is not that much problematic. But the first question was about the photon and how it is going to interact in specific different interactions. So we have seen photon can take part in EM interaction, photon cannot take part in weak interaction, photon cannot directly interact with gluons, photon can directly interact with quarks. Okay, very good. So this is about the first question. Now come to the second question. Second question is very similar, but instead of photon we are going to talk about W boson. Which of the following statements is or are correct? W boson can take part in electromagnetic interaction. W boson can take part in weak interaction. W boson can directly interact with gluons. W boson can directly interact with quarks. Okay. So W boson. W boson means W plus, W minus. So these two are the mediator for weak interaction, right? So obviously the second answer is the correct one. W boson can take part in weak interaction. There is no doubt on that. But coming to the first option, W boson can take part in electromagnetic interaction. As far I told that if gamma, instead of gamma, if anyone wants to take part in electromagnetic interaction, they should have a non-zero electric charge, so that it can it can take part in electromagnetic interaction. Now W boson has W plus and W minus, two particles, two members are there, and both have non-zero electric charge. Right? W plus has plus 1, W minus has minus 1. So as both have non-zero electric charge, so that means W boson can take part in electromagnetic interaction. Okay? That is also true. Now W boson can directly interact with gluons. Okay, first of all, W boson is not the mediator of strong interaction. So anybody who wants to take part in strong interaction, they should have color charge, because gluon is the mediator for strong interaction. But W does not have any color charge. So W boson cannot directly interact with gluons. Okay? So this is not correct. Now W boson can directly interact with quarks. Okay. So for this case, W boson has weak charge, because that is the mediator for weak interaction. Now the main thing is that quarks has weak charge or not. If quark has weak charge, then that will directly interact with W boson. If it does not have any weak charge, then obviously it will not directly interact with W boson. Now let me see quark has weak charge or not. Weak charge means basically in standard model there is in the standard model we are considering a gauge symmetry, right? And in that gauge symmetry, three terms are there: strong interaction, weak interaction, and electromagnetic interaction. So the total gauge symmetry, I can write it like SU3C, SU2L, U1Y. If you did not see that one, then I will explain, but I hope you saw this gauge symmetry in standard model. So here this is corresponding to strong interaction, this is corresponding to weak interaction, and this is corresponding to EM interaction, right? So the thing is, weak interaction, any particle has weak charge or not, that will depend on two parameters. One parameter is I3. I3 means the third component of isospin. And another is Y, hypercharge. Now you will ask me why is there? Because electromagnetic and weak interaction both are connected and both are giving us electroweak interaction. So electromagnetic has the generator Y and weak has the generator L. Now the weak charge means the particle should have a non-zero I3 value, or it should have a non-zero Y value. Y means hypercharge. Now come to quark. For quark, I3 and Y, at least one of them should be non-zero. So let's say U, I am talking about U. So U and D were in the family. So I3 for U is half. So that means it is a non-zero. So as I3 is non-zero for quark, let's say U, then we can say that our U has a non-zero weak charge. Now if it has a non-zero weak charge, it will directly interact with W boson, which is the mediator of weak interaction. So W boson can directly interact with quarks. The options are A, B, D. Okay. So the main thing, whatever I want to focus is that whoever wants to take part in any specific interaction, they should have non-zero charge on this specific interaction. That is the main thing. I mean, we are not taking care about the mediators right now. Mediators should be take part in that specific interaction. That is in general principle. But other than these mediators, whoever wants to take part in that specific interaction, they should have the non-zero value, non-zero charge under this specific interaction. So till now, there were two questions. One was about 2 gamma and another one was on W boson. Okay. So, yeah, third question. Obviously, third question is a very simple question, so maybe we will not have that much time on that question, but let's see. Find the missing particle in E plus mu E going to mu plus something. So, what is something? So, we have, I mean, in many times we have done these things, but still, E plus mu E, mu plus something. So what will be something? So for this we have to check Q, B, L, right? So Q means the charge, electric charge. Electric charge is plus 1, this is 0, this is plus 1. So whatever the charge will be there, that will be 0. That means the neutral charge should be there. And you can see among these 4 options are neutral. So among these 4, anyone can be the actual one. Now for baryon number, no one is baryon, so obviously the other one should not be the baryon. Now come to L. L means Le, L mu, L tau. Let's say Le. So if Le we are talking, for E plus, Le is minus 1. For mu E, Le is plus 1. So as a whole, in the left hand side, it is 0. Now come to Le for mu plus, it is 0. So obviously whatever this will be, it should not be charged under Le. That means this particle will not be in electron family. It can be muon family or it can be tau family. Now let's check it can be muon family or not. E plus 0, mu E 0, mu plus, it has minus 1. Now here it should be plus 1, otherwise as a whole it will not give us 0. So plus 1 means it is a particle in muon family with charge 0, electric charge 0. So what will be that particle? The particle will be neutrino, mu, because plus 1 is there. So mu. Now see, this is the case. B option. Mu. Okay. So to have the missing particle, we just need to check whether, we just need to check what will be the value for Q, B and Le, L mu, L tau. Then we can identify what is the missing particle. Okay. Yes, question number 4. Find the correct statement for E plus E minus going to ZZ interaction, where Z denotes the gauge boson of mass 91 GeV by C square is. Okay, there are 4 options. We will go one by one. What is the correct statement? What is the interaction? The interaction is E plus E minus going to Z. And the mass of Z is 91. I'm not writing here the unit. Okay, obviously I should write it. Right. G by C square. So the mass of the electron is 0.511 MeV by c square. If I convert this one to GeV by c square, then it will be like 0.511 into 10 to the power minus 3 minus 3 GeV by c square. Okay, this is the mass of the electron or positron. Now come here in the option A. Not possible, I mean this interaction is not possible as mass of ZZ is larger than that of electron. Okay, let me write here again properly. So actually the thing is to have this interaction we should satisfy the energy conservation, right? Because in every interaction energy should be conserved. Now the energy means it has two parts, kinetic energy and rest mass energy. So whatever we are talking that ME as 0.511 into 10 to the power minus 3 GeV by c square, or MZ is 91 GeV by c square, all these things are rest mass. Okay. Now let's say we have a very high kinetic energy of electron and positron, very high kinetic energy, so that the total energy for electron and positron as a whole in that left hand side is equals to the total energy of right hand side. Even though I know the rest mass of electron and positron are far smaller than the rest mass of Z, but if we have a very high kinetic energy, so that the total energy of the left hand side should be equals to right hand side, then the interaction should be possible. Okay. So not possible as mass of ZZ is larger than that of electron, that is not correct. I mean in rest frame obviously it will not gonna happen. Like let's say if electron and positron were in rest and they are just colliding to both and they are making ZZ, that is not gonna happen. But let's say E plus and E minus has very high kinetic energy, so that the total energy of the final particle will be such that it will produce 2 Z boson. That can be possible. Okay, now coming to B option. Possible with sufficiently large kinetic energy for the electron and the positron. Just I told that one. Possible even with vanishing kinetic energy of the electron and positron. Now see, they are telling that with vanishing kinetic energy of the electron and positron. That is not correct. Because vanishing kinetic energy means there is only rest mass energy. And the rest mass energy of electron and positron are very small with respect to Z. So, the vanishing in the case of vanishing kinetic energy, it will not happen. So, this is not correct. Fourth option. Not possible because we have spin half particles in the initial state, whereas in the final state are spin 1 particles. Okay, now coming to spin. Actually, obviously the electron total energy should be conserved, that is fine, as well as spin should also be conserved. I mean like total spin, angular momentum, all these things should be conserved. Now they are telling that in the left hand side this is spin half particle, in the left E plus, E minus is also spin half particle, and this is a spin 1 particle because these are the bosons. Now they told that this is not gonna possible, but obviously it's incorrect because this is, let's say, S1 and S2. This is again S1, S2. Actually S1 prime, S2 prime. So quantum mechanically it should be S1 minus S2 to S1 plus S2. So what will be the value for that? S1 minus S2 means 0. S1 plus S2 means 1. So 0 and 1 can be the possible value of angular momentum, spin angular momentum. Now coming to the right hand side. In the right hand side, h1 minus h1 prime, h2 prime, 2 h1 prime, h2 prime. So for this case, what is the value? 1 minus 1 0, 1 plus 1 2, and 1. Now you can see 0 1 0 1 2. That means it can be possible. No problem on that. So option number 4 is not correct. The correct option is only B. Okay. If you have any doubt, then you can ask me, because these are very not simple, I mean like tricky as well as very interesting also. Okay. Yes. Fifth question. A particle X decays to two particles A, B. That is, X is going to A plus B. If X and A are fermions, B is what? Is necessarily a boson. Could be either fermion or a boson. Is necessarily a fermion. Let me answer this question. X is going to A plus B. X is fermion. A is also fermion. Now what about B? See, at the very first, if it is a fermion means it has a spin half. I mean half integral of spin. Half h bar, n h bar. N is 1, 2, 3, 4 like that. So, let me write here X, A, B. So spin. This has spin half, let's say. It's already told that it's a fermion. A is also a fermion, that means it's also half. Now coming to B. B is X, let's say. Now, in the left hand side only one value is there, half. In the right hand side there is half and X. So the total angular moment, value will be like half minus X to half plus X. But it should be equals to half, because in the left hand side only one half value is there. So half minus X, let's say it should be half. I am taking. Then X is 0, right? Now again let's say half plus X I am talking. That should equals to half. So X will be okay, fine. It is also half. Half minus half. Okay, that is also 0. But I mean, the main thing is that, let's say X is 1. That is also fine. Why? Because half minus 1 or half plus 1. Half plus 1 is 3 by 2. Half minus 1 is again half. So this half can be this half. So I am talking in this sense that X should be 0, 1 like that. If let's say I am talking X as half, then X was A plus B. So it is half, let's say this is also half, let's say. Then what will happen? This is half, but this will give us 0 or 1. But that is not the correct option. So the boson, the B should be boson with spin, like positive integer, integer of H bar. Like 1 H bar, 2 H bar, 3 H bar, something like that. It will not be the fraction like half, 3 by 2. It should not be like that. So B is necessarily a boson. Option 1 is the correct one. Okay. Okay. From question number 6, these questions will be little bit tricky. So maybe we have to spend some more time on these questions. Let's see. Which of the following processes are solely mediated by W boson? Choose all correct options. To answer this type of questions, we have to check first that whatever the interaction they are giving, that is allowed or not. First of all, we have to check. If it is allowed, I mean obviously in most of the cases it should be allowed. When we will be sure that it is allowed, then we have to check that in which interaction they are falling. Then we can say that okay, if this is the interaction they are falling, then what can be the interaction medium? Then we can control. They are asking that which of the following processes are solely mediated by W boson. Solely mediated by W boson means only W boson is the main responsible one to have these following process. It can be possible among these four options, one or more than one interaction is such like that it is mediated by W boson as well as it is mediated by some other particle. But they are asking only this interaction we need to check which are solely mediated by W boson. Okay. So just check one by one. First one, mu plus mu e bar going to e plus mu bar. First of all, we have to check this is correct. I mean, this is allowed or not. This is very much allowed because the charge, you can see that charge is very much allowed. Now coming to lepton number and all these things. Let's say this is L mu we are talking. This is -1, 0, 0, -1. For LE, 0, -1, -1, 0. So I can see that this is fine, no problem. So we have already checked that this interaction can be possible. Very good. Now coming to what will be the and which type of interaction it is. To see this one, obviously we can tell that this is a weak interaction. Why? Because neutrinos are present. Whenever neutrinos will present, that will be definitely a weak interaction. Because neutrinos only take part in weak interaction. Okay? So very good. It is weak interaction. Now weak interaction means what are the mediator for weak interaction? We know that mediator for weak interaction is W plus W minus and Z0. Now we have to see that this interaction can be followed by only W boson or Z boson can also take part here. So first of all mu plus, okay. So the mu plus mu e bar, these are the incoming particles and the outgoing is E plus mu bar. Now see the Feynman diagram. I will just write here the Feynman diagram. Mu plus is going to mu bar. Mu plus mu bar. Then there is one something mu e bar E plus. And what it will be? This is mu plus coming. There should be W. Otherwise in that vertex charge will not be satisfied. Okay. So mu plus is this one. And let's say this is W plus and it is going this side. So what does this mean? This means that W mu plus is coming in that vertex and from this vertex W plus is going. So as a whole this should be chargeless and reach because mu bar is the zero electric charge. Now coming to this vertex. This does not have any charge. This one was E plus, sorry W plus, that means plus 1 charge. It was incoming for this vertex. And for E plus, it is the outgoing one. So it's fine. Now you can see that this interaction can be possible only through W plus. W minus can also be fine because you can write it like that. in that direction W minus. Then it is fine. Mu plus, mu bar, mu e bar, e plus. That is also fine. But the main thing is that either W plus or W minus. As a whole, it can be done only through W boson. Why I am telling you that only through W boson? Why not Z boson? Let me check this one also. It should be through Z boson or not. Now see, Z boson means what? Z boson means in that vortex, Z does not have any electric charge. So whatever will be the incoming particle, that should be the, like in that vortex, the charge should be conserved, right? So here, in that interaction, if I replace W by Z, then in that vortex it will not gonna possible, because mu plus is plus 1, this is 0, this is 0. So this vortex will not be happening. Another thing it can be possible, let's say I am writing this type, mu plus mu e bar, both are coming and these two are going, and Z boson. This is also not correct, because obviously the charge is not conserved as well as the lepton number is also not conserved. So this whole process is not correct. This is also not correct. So this interaction should only be possible if W is the mediator. So whatever they are asking for, this question, this answer has the answer. Okay. So now come to W plus W minus mu e bar. W plus W minus mu e bar. Mu plus mu minus mu e bar. Again, by seeing that, we can definitely tell this is a weak interaction, because neutrino is present in that interaction. So this is weak interaction, and what is the mediator for weak interaction? W plus W minus Z0. Now let's check one by one. Either W plus W minus will be the only one, or both the one. Both will be did here. First of all, W plus W minus is why we are talking about mu plus mu minus. Sorry, mu plus mu minus, mu plus mu minus. Then mu e bar. If I write this type of vortex, then the mediator will be Z. Now, let's check about W. W can participate in that interaction or not. If we want W to participate, then we have to do like that, mu plus, and there is maybe bar or maybe something like that. But this vertex is not correct because there is no lepton number conservation. Lepton number is L mu is minus 1 here. This has Le minus 1. So this vertex should not be the correct one. Okay. So this interaction is solely mediated by Z0. The option number B is not the correct one. Now come to mu plus E minus mu bar. Mu plus E minus. Mu bar. You can check that all the things are all the things are conserved here. Lepton number, charge, virion number, all the things are conserved here. Okay. So this is gonna happen. But through which interaction, that we have to check. Obviously, neutrino is present, that means W plus W minus, and Z0 can be the mediator. Now see which one will be the mediator. So I am writing here W mu plus. This. So if mu plus is coming this side, then obviously it will be mu bar. Otherwise, lepton number will not be the correct one. And let's say W. And E minus is coming, and mu E is going. In that vertex also, the things are fine. So this can be one Feynman diagram. Okay. Now, let's check another Feynman diagram, if it is possible or not. This one, I mean like, okay, if W means, if W plus is possible, then W minus is again possible, no problem. Now, Z is possible or not? For Z, obviously this type of things we can say, right? For these things Z cannot be there, right? Because of the charge is not conserved here. So for having the Z, we can have only the S channel. So mu plus E minus Z mu E mu 1. But the thing is that here in that vertex, electric charge is fine, conserved. But lepton number is not conserved anymore. Okay? So this is not correct. Again, this interaction is fully W mediated. So option number C is again fully W mediated. Now coming to mu plus mu minus E plus E minus. For this case, obviously this is possible interaction, I mean allowed interaction. Now, see here neutrino are not present directly. So we can't say that it is only weak interaction. It can be possible that it is electromagnetic interaction and weak interaction. How? It can be possible like this one, mu plus, mu minus, E plus, E minus, gamma. Through gamma it can be possible. Again, this can also be possible. Mu plus, mu minus, E plus, E minus, Z. That can also be possible. But this type of process will not happen because mu plus cannot go to E plus. That is not correct. Now only these two can happen. But among these two, no one is W. So again, option number 4 is not correct. Okay? So the correct option will be 1 and 3. Till question number 6, if you have any doubt, you can ask. Is there any doubt till question number 6? I think no. Okay, now coming to question number 7. Which of the following statements is or are correct? Both Z and W bosons can take part in electromagnetic interaction. Both photon and Z bosons are massless. W boson directly interact with quarks. Gluons mediate weak nuclear interaction. So first one, both Z and W boson can take part in electromagnetic interaction. That is not correct. Why it is not correct? Because W can interact in electromagnetic interaction. It has W plus W minus. But Z does not have any electric charge. So it cannot participate in electromagnetic interaction directly. Okay? So first one is not correct. Both photon and Z bosons are massless. That is not correct. Photon is massless. That is fine. But Z boson is not massless. Mass of Z is 91 GeV by c square. So it is not massless. Now coming to third option. Z bosons directly interact with quarks. Yes, that is correct because we just talked right now that quark has weak charge. And if it has weak charge, W boson has also weak charge. So W boson directly interact with quarks. Gluons mediate weak nuclear interaction. That is obviously not correct because gluon is the mediator for strong interaction. It is not the mediator of weak interaction. Okay? So this is not correct. Okay, fine. This question has already done. Now we will come to the next question. Select all possibilities. The process U plus d bar going to U plus d bar is mediated by which interaction or which particle? Okay. U plus d bar going to U plus d bar. First of all, let me check Z boson. U d bar U. No, it is not happening because this has 2 by 3, this has 1 by 3. So I cannot write it like that, but I can write it like U d bar and Z. That can be possible. Okay? So Z boson can mediate in that process because U, D both have weak charge. So it can participate in a weak interaction and Z is the mediator for weak interaction. So it can be possible. Now coming to photon. U d bar via gamma. That is also fine. You can see. So, because it has charge, both can directly interact with gamma. That is also fine. Now W boson. So for W boson, this type of interaction should not be there. But for W boson, we can do one thing. Here is U. Here, let's say it is d bar. How I can write it? Let's say this is 2 by 3. This is 1 by 3. Right? So, and let's say this is W. So 2 by 3 plus, not plus, let's say minus 1 by 3. Sorry, minus 1. So you can see it will be the value wait. U d bar. D bar is 1 by 3. If it is this side, then x should be 2 by 3. And let's say this is this side is equals to x plus 1 by 3. X is 2 by 3 minus 1 by 3, so it is 1 by 3. Okay, so W is not possible here. Why? If W is there, then also U cannot go to D bar. U is 2 by 3 and D bar is 1 by 3 charge. So it cannot go through W. Again, that cannot also be done. Because D has a charge minus 1 by 3. D bar has 1 by 3. U has 2 by 3. So if W is again there, then it will not gonna happen. So Z boson is fine, photon is fine, W boson is not fine. Gluon. Gluon for what we have to check? Gluon is like U plus D bar going to U plus D bar. Both have strong charge, color. So it can be possible to have these things, gluon. That can be fine. U, D bar. It can be fine. because it has the color charge. So this is fine. So A, like Z boson, photon, gluon. Actually, in some interaction, we can see Z boson can also participate through this type of interactions, as I told, U, D, bar and all. Let's say I am talking about U plus D going to U plus D. In this case, Z boson should be there. Why? Sorry, W boson. U, D. U is 2 by 3, this is minus 1 by 3. So 2 by 3 minus 1. See, 2 minus 3, yeah, minus 1 by 3. See? And here it is D, U. So W minus. This is coming. This will also come. That will like that. This one also fine. Here D is minus 1 by 3 and W is going, that means okay, that is equals to 2 by 3 minus 1. 3, 2 minus 3 minus 1 by 3. Okay. I have to put my charger. Just a minute. Okay. So this is the case. Now coming to second question. Next question. A pair of electron and positron can annihilate to produce two photons. E plus, E minus can go to gamma gamma. That is always true because you can see the mass of electron and positron is far larger than mass of photon, which is massless, right? So in a rest frame also, whenever the E plus and E minus are in rest also, that can also be fine. So a pair of electron and positron can annihilate to produce two photons. It is always true. Okay? There is no problem on this side because charge, baryon number, lepton number, all these things are conserved here, and then mass is also conserved, lepton angular momentum, linear momentum, whatever you will tell, all these things are conserved here. Okay. Next question is here, a pair of electron and positron can annihilate to produce two Z bosons. E plus, E minus going to Z, Z. For this case, you can see charge wise it is very good, no problem. Other lepton number, baryon number, these are all very good, no problem. But the thing is that if I talk about mass of electron is 0.511 into 10 to the power minus 3 GeV by c square. So m plus m e minus. If I want to write it in the condition when e plus and e minus are in rest, so it will be of the order of 10 to the power minus 3 GeV by c square. Because 0.5. But what is the mass of Z? The mass of Z is 91 GeV by c square. And in the right hand side, Z is there. So it's obviously 182 GeV by c square. Now obviously we know that these are the only simple rest mass. If I take care about the electron mass, kinetic energy and the total energy, let's say total energy of the left hand side is equal to the total energy of right hand side, then this interaction is possible. But the thing is that to have this type of interaction possible, we need to have the kinetic energy for electron and positron is too much. Too much is in the sense I am talking. This is minus 3 GeV and this is 182 GeV. So we need more, let's say 182 GeV kinetic energy to get rest ZZ. So it's very difficult to have 182 GeV kinetic energy to produce two Z boson here. I'm not telling that it will not gonna happen any time. It can be happen. This interaction can be possible even when, only when the kinetic energy of E plus and E minus are very large. This is the main problem in getting this type of interaction. But E plus and E minus can decay to two photons very naturally, very frequently. But to have Z and Z, that will be a little bit more problematic. So for this question, I cannot tell that true or false. It can be the answer maybe if E plus and E minus have very large kinetic energy. So true false is not the actual answer for this because we don't know the kinetic energy of these particles, right? So if we know the kinetic energy of this particle, then only we can tell whether E plus E minus will go to Z, Z or not. Okay, now come to the next question. Choose all the right answers. In a collision of electron and electron, which of the forces are involved? Electron, electron. Which of the forces are involved? First of all, to have electromagnetic force, we need a charge particle. Electric charge particle. Electron is electrically charged and it has the electric charge minus 1. So it can participate in electromagnetic force. Okay, very good. Strong force. To have it in the strong force calculation, it should have the color charge. But electron does not have any color charge. So it will not interact with strong force. Involved with strong force. Now come to weak force. So electron has weak charge. That means electron can involve in weak force. So the option is 1. Electromagnetic force. 3. Weak force. These two are the correct options. Okay, now coming to the next question. Select all the allowed reactions below. All the allowed reactions below. Let's take first option. U plus U bar going to U plus C bar. To see this type of interaction, by seeing this one, we can say that, okay, charge is very good, fine. 2 by 3 minus 2 by 3. This is 2 by 3. C has minus 2 by 3. C has Q as 2 by 3, but C bar is there, so that is minus 2 by 3. Baryon number, this is also baryon, this is also baryon, this is also baryon. Actually, it is 1 by 3. This is 1 by 3. Like minus 1 by 3. This is 1 by 3. This is minus 1 by 3. That is also fine. Lepton, anyone, among these four, no one is varying lepton. So, lepton is also fine. But the thing is that this interaction possible if I want to write here the Feynman diagram? Then what will be the Feynman diagram? U bar, C bar. This one can be done like what? Through, let's say, gluon. Or it can be possible like U bar, U C bar, gluon. But the thing is that gluon does not have any flavor charge. It has color charge, but it does not have any flavor charge. So this cannot go to this one. U goes to C, that means what? The flavor is changing. But gluon does not have any flavor charge. So as it does not have any flavor charge, it cannot transform U to C or U bar to C bar, etc. So this is not possible. Now coming to U bar, mu plus mu minus. U plus U bar, mu plus mu minus. See here, charge 2 by 3 minus 2 by 3, 1 minus 1. Baryon 1 by 3 minus 1 by 3, 0, 0. Lepton 0, 0 minus 1 plus 1. All the things are fine. And to have the Feynman diagram also I can see U bar going to mu plus mu minus, Z or gamma, whatever. That is also fine. So we can say that this expression can be done. Now E plus U bar going to mu E bar D bar. E plus U bar mu E bar D bar. Okay. E plus mu E bar. E plus U bar mu E bar D bar. U bar, mu E bar, D bar. Now check the charge first. Plus 1. This is minus 2 by 3. Yes. So the charge is 1 by 3. This is 0. This is 1 by 3. So that is fine. Now coming to baryon. This is not baryon, this is antibaryon. This is not baryon, this is also antibaryon. Fine. Lepton, let's say Le. This is minus 1, this is 0, this is minus 1, this is 0. So this is also fine. Now let me write here the Feynman diagram. E plus can go to mu E bar. Then U bar can go to U D bar. It can be possible through W. Why? W can change the flavor. Like U is there, U has minus 2 by 3. This has 1 by 3. So minus 2 by 3 plus 1. What will be the answer? Minus 2 plus 3, which is 1 by 3. Okay? So this will be like plus. Now you can see this is possible. So the interaction is allowed. Now E plus D mu E bar U. E plus D mu E bar U. For this case, obviously we'll just check Q. 1, minus 1 by 3, 0, 2 by 3. So 1 minus 1 by 3 is what? 3 minus 1, 2 by 3. Okay? Then left on LE. Minus 1, 0, minus 1, 0. Baryon. 0, 1 by 3. 0, 1 by 3. Fine. Now coming to Feynman diagram. E plus going to nu E bar through W. D going to U. Is it possible? Let me say. This is minus 1 by 3. Let's say plus 1. That is 3 minus 1 plus 2 by 3, which is 2 by 3. That is fine. So it will come as W plus. Okay. So this interaction is also fine. Oh, this is fine. So option number B, C, D, all these three are allowed. Now in the next question, which of the following interactions are not allowed? We will see which is the not allowed case. So not allowed case also we have to check that allowed or not allowed thing. So let's say first one. U plus U bar going to E minus E plus. Check Q 2 by 3 minus 2 by 3 minus 1 plus 1. Fine. Baryon number 1 by 3 minus 1 by 3. 0 0. Lepton number 0 0 minus 1 plus 1. Fine. So all the things are fine. Now U bar, okay? So it can be like U bar can go to E minus E plus. It can be Z or gamma. That is also fine. So this is not allowed, is not correct. That means it is allowed. Now come to second option. U plus E minus nu bar D. Nu bar D. Okay. Here there is a tree. Just see. Q is 2 by 3. It is minus 1. This is 0. This is minus 1 by 3. 2 by 3 minus 1 if I write 2 minus 3, that is minus 1 by 3. This is fine. Now come baryon. 1 by 3, 0, 0, 1 by 3. That is fine. Le 0. This is 1. A electron is there. This is minus 1. This is 0. So it is not correct. So if electron number is not conserved, then obviously it is not allowed. So not allowed. Now coming to next question. U d bar E plus E minus. U d bar E plus E minus. Check Q. 2 by 3. That was minus 1 by 3. I mean D was minus 1 by 3. So D bar is 1 by 3. And it is plus 1 minus 1. But you can see that 2 by 3 plus 1 by 3. It is coming as 3 by 3, which is 1. So delta Q is not equal to 0. So as a charge is not conserved, that is not gonna happen. So not allowed. Now coming to next. U plus E plus nu E bar D. U E plus nu E bar D. Charge 2 by 3 plus 1 0 minus 1 by 3. It is 2 plus 1. See here 2 by 3 plus 1 5 by 3. But here it is minus 1 by 3. So this is also not correct. Delta Q is not equal to 0. U plus E plus nu E bar D. So that is not also fine. So it is also not allowed. So the not allows are B, C, D. So now you can come to the next question. Which of the following processes are solely mediated by Z boson? Now coming to Z boson. Similarly, whatever it was there for W boson, now it is Z boson. For Z boson case, first check mu plus mu minus mu e mu e bar. For this case, let's write here. Okay, this is weak interaction. Obviously, all of we know that. So, it is weak interaction because neutrino is present here. Now, weak interaction means W plus W minus Z0. So, for this case, it can be possible to have mu plus mu minus Z mu e bar. It can be possible. But, will it be possible through W also? To have it through W, we have to check that mu plus is going to mu A or something. But it is not correct. Right? Mu bar. Lepton number should not be violated in any nuclear reaction. So W cannot be the mediator for this case. So it can only possible through Z. Now mu plus mu minus mu bar. Mu plus mu minus mu bar. Again, as neutrino is there, so obviously it will be only W plus W minus or Z0. Now coming to W plus W minus or Z0, let me write here Z0 only first. Mu plus mu minus Z. Mu bar. It is fine. Now we have to check whether it is through W or not. Mu plus mu bar. Mu minus mu W. It can be possible. Why? Mu plus is coming here, mu bar is going there. And the lepton is also fine. Lepton means here it is minus 1, incoming, and outgoing is also minus 1. Here also similarly it is plus 1, it is plus 1. So it is fine. So in that case, like mu plus mu minus going to mu bar, here mu and W and Z0 both are there. So solely mediated will not be the correct one. So W plus and Z0 both are there. Now coming to mu plus mu e bar, E plus mu e bar. Mu plus mu e bar, E plus mu e bar. For this interaction, let's check LE. 0, minus 1, minus 1, minus 1. So you can see delta LE is not equal to 0. So obviously there is no point of having any nuclear reaction. Now mu plus mu e bar, E plus mu bar. Mu plus mu e bar, E plus mu bar. For this case, LE is 0, minus 1, minus 1, 0. L mu is minus 1, 0, 0, minus 1. These are fine. So this can be possible. Now coming to the interaction, which mediate will be there. Obviously it is a weak interaction. So W plus, W minus and Z0 can be the mediator. So let's check. Mu plus mu bar, W, mu e bar, E plus. That is the only possible interaction. Through Z it will not happen. So again in that question whatever they asked that solely mediated by Z boson, that is also not correct. Only W. So the correct option is A, which is only solely mediated by Z boson. Okay. Now see again these questions. Which of the following processes are solely mediated by W boson? Just quickly check this. Okay. 1, 2, 3, 4. Okay, as these 4 are all neutrinos present, mu e, mu mu bar, mu bar. So obviously these are mediated by w plus w minus and z0. But which are the responsible one? So mu plus mu minus going to mu bar. For this case, this is only possible through this one. Mu plus mu minus mu bar z. Because there should not be any w. If the w is there, then vector number will be validated. Now like mu plus mu minus mu bar. Mu plus mu minus mu bar. For this case, z can be fine because of this interaction, or it can be found by this one, mu plus mu bar, mu minus mu through w. So this can be fine. But solely mediated by w motion, that is also not correct. So this option A is not one, B is also not one. C, mu plus mu bar, E plus mu bar. We have already checked right now, just before some time, that LE is not conserved here. So obviously delta LE is not equal to 0. So it is not gonna happen. Now D, mu plus mu bar, E plus mu bar. Mu plus mu bar, E plus mu bar. This is fine because LE is like 0, minus 1, 0. L mu is minus 1, 0, 0, minus 1. Okay? This is fine. But the thing is that mu plus mu bar, mu bar, E plus W. This is fine. But it cannot through the Z. That is not correct. So the last one is only through Z, A W. So D is the correct option. W minus O. Okay. Now the last question is pi plus going to E plus mu E. Decay is mediated by a what? Okay. Pi plus decays to E plus mu E. As mu E is present, that means weak interaction should be there. Now weak interaction means W plus W minus Z0. Strong interaction will not be there. That means gluon will not be there. Photon will also not be there. Either among these two, one will be there. Which one will be there? Pi plus. Pi plus means U, D bar. So, let me write here U plus D bar going to what is there? E plus mu. Okay? So right now I am writing here U D bar, then something will be there, E plus mu. It can be possible via W. How? See, this is W minus, let's say, and this is coming, and this is going. Let's say W plus. And it is 2 by 3. U is 2 by 3, right? It is 2 by 3. And this is also coming. So 2 by 3 minus of minus, that means plus 1 by 3. So it is 1. And W plus is also 1. W plus should be there because U d bar. Z will not be fine. This whole, this is also not fine. This one is also not fine through Z. Only W plus can be the one. Because you can see the charge is also conserved and all the lepton number, baryon number, all these things are conserved here. So this option is W boson only. Z is not fine. Okay. So these are the questions. I think it's fine. Yeah, it's the last one. So these are the questions for today's class. Yes.
Excuse me, ma'am.
Yes.
Hello.
Yeah, can you hear me?
Ma'am, in the last assignment 10,
Ah.
we have discussed transition amplitude.
Which
What
amplitude?
option is given correct? Incorrect.
Which amplitude? Flux. Flux.
Last assignment 10,
Uh-huh.
we have discussed transition amplitude.
Oh, transition amplitude. TFI.
I think question 5 or 6. What option is given incorrect?
I mean, this year assignment you are talking.
Yes, ma'am. Last 10, assignment 10.
Yeah, 2024.
Question number 5, I think question number 5 or 6.
I mean, 2024, right? Hello?
Question number 5, assignment 10, question number 5.
Yeah, like 2024 question you are talking, right? Am I audible?
Yes, ma'am. Ma'am, in the last assignment 10, question number 5.
Okay.
5 or I think 10.
Let me see that. Okay. Can you hear me? Hello.
Yes, ma'am.
Can you hear me? Okay.
Yes, ma'am.
Okay. So, uh, this one,
Assignment 10.
which? Okay. Which one?
Question number, I think, third.
This one.
We have discussed option second is correct, but sir given.
No. The main thing is that, okay. Just a minute. See the figure here. Figure is P1, P3, P2, P4. Okay. And E minus, E minus, E minus, E minus. So, it is different from the previous one, whatever we have discussed. Let me tell you what is the difference. Is there any space? It was P1, okay. It is P1, this. So P1, P2, P3, P4, E minus, E minus, E minus, E minus. This is the interaction, right?
Yes, ma'am.
Okay, and they are asking, what they are asking, let me see here. What are the similar relation relationship PMP2 scattering on both each other are represented by the diagram below. Therefore, moment are scattering and P1, P2 is coming and P3, P4 is going. As given in the diagram, the momentum of the exchange photon is Q. The wave function of the electrons are given by U1, U2, U3, U4. Which of the following correctly represents? Okay, fine. Just see. This is U1, U2, U3, U4. These are the things. E to the power minus I pt I am not writing here. Okay, the thing is that here E minus is coming, E minus is going, E minus is coming, E minus is going, and this is gamma, through gamma, let's say. So the interaction is E minus going to E minus. The main difference between this one and the previous, whatever we did, that one was in the S channel. Right now it is in P channel. So I will tell what is the difference between these two. TFI. TFI has what? Minus I square is there. Then 2 pi to the power 4 is there. then there will be some vertex, then 1 minus 1 by q square for gamma, and there will be another vertex, and delta 4 should also be there, right? So let me write here first delta 4. Delta 4 is what? Delta 4 is simply, okay, delta 4 will be like P1, P2, P3, P4, right? So it's simply P1 plus P2 minus P3 minus P4. That is very good. But the vertex, this vertex. Now as this is a T channel, so let me write here A vertex, B vertex. So for A vertex, it will be, see here, this one is outgoing particle. So U3 will be there bar, then let's say gamma mu, and coming is U1, so it will be U1. For B vertex, it will be outgoing is U4, so U4 bar, gamma mu, this is U2. So for A and B vertex, this one will be like U3 bar, gamma mu U1, U4 bar, gamma mu U2. This is for T channel, but S channel was there, it was like that. For this case, let's say P1, P2, P3, P4. For this case, 1 and 2 will be in that vertex, and 3 and 4 will be another vertex. But here 1 and 3 will be a one vertex, 2 and 4 will be in the vertex. So maybe sir has given the correct option. Yes, 1 and 3 and 2 and 4. Do you understand the point?
Yes, ma'am.
Yeah, because that one was the S channel, right now it is the T channel, that is the difference. So actually I did not tell the S channel and T channel, so that maybe I thought that A and B vertex, if I write then only you can understand. The main thing is that the interaction in which U1 or U3, U1 or U2, in which vertex the interaction channel is there. So here A is U1 and U3, B is U2 and U4. That's why U1, U3, U2, U4. But if this type of things are there, where P1, P2, P3, P4, then U1, U2, like U1 and U2, and there U3, U4. Okay? So I think this is correct. Yes, this is correct.
Ma'am, next question number 4. Is the question number 4 in this assignment?
Okay. Question number 4. Q.
Yes.
Okay. Now Q value. The same question is there. Okay. Right. I mean similar question, not same. Okay. So E minus, E minus, E minus, E minus. Then this is A, this is B, this is P1, P2, P3, P4 and Q. Now see here, what is the Q value? Let me write here A. From this A vertex, I can write here, this is coming, this is coming. This is also coming, this is going. So for this vertex, P1 is coming. Let's say Q is in that direction. Let's say. So Q1 is going, Q is going, and P3 is also going. So Q will be P1 minus P3. Now for vertex B, P2 is incoming, Q is also incoming, P4 is outgoing. So Q will be P4 minus P2. Now if I change the direction of Q, then nothing will change, only the sign will change here. Let's say P3 minus P1, and here P2 minus P4. Now see the options. P2 minus P1, P2 minus P4 minus P2. P4 minus P2 is what's correct, because I have seen the P4 minus P2 or P2 minus P4. And another option is P2 minus P1. P2 minus P1 is not correct, because you can see P2 and P1 are in these different vertices. That will not correct. Q will be only P1 minus P3 or P3 minus P1 or P2 minus P4 or P4 minus P2. These four options can be possible. Okay. Maybe I can again inform sir about this. I mean, give all the correct options. Correct option P1, P3 minus P1 is correct, and P4 minus P2 is correct. B and C will be the correct option. A and D are not the correct one. So what did you write here? Hello?
Ma'am, B and C are correct.
Yes, P3 and P1, P2 and P4. You can see na in that plot. Okay,
Yes,
maybe.
ma'am.
Yeah. So simple thing is there. P1, P2, P3, P4, and this is Q. So obviously
Yes, ma'am.
P1, P3,
P3 minus P1 is Q. Yes, yes.
P1 and
Right.
P3 will be there, or P2 and P4 will be there. But
Yes.
anyhow, P1 and P2 are not be the Q, as well as P3 and P4 will not give the Q. So the correct option will be P3 and P1 or P4 and P2. But I don't know why P2 and P1 they have written. Maybe I will ask sir to cross check again. Yeah, fine. Yeah, I'll inform sir. Is there any other question problematic here?
No, ma'am. No.
Okay, I don't know why that much typos are here. Okay, fine. See, this is the same question. Okay. This is also the same question. This is different. No, it's exactly similar. Okay, fine. Maybe this week, is that the same question this week also? Whatever I asked, which of the functions of words can take part? Okay, it's a little bit different. But again, W was not there. Okay. Oh my god, this is also similar. This is also similar. Okay. Not allowed, mediated by Z boson, mediated by W boson. Oh, very similar question. Okay, fine. So, is there any doubt on this today's class? Because today's class is a little bit lengthy as well as very much information was there. You have to check each and every interaction, how it will happen. That is the thing. So,
Okay.
okay, so maybe today we can stop this class. And the next class will be the last class formally, but informally there will be another class. I think all of you have already knew that one, but if you did not know, actually the next to next class will be simply only on the total topic, whatever till now, week 12, up to week 12, whatever we are going to teach, we are going to learn, that will be only base of these questions. It will be total syllabus question will be there. Obviously, there will be no direction, there will be no link with the exam pattern. But I will tell about the exam pattern, how the exam pattern will be, and as well as what can be the question. I am not gonna prepare the question as well, so I don't know what will be the question. But what can be the question? What are the important questions from each topic in nuclear particle physics that we will discuss in the next Friday, because next Friday will be week 12, and after that one, next Friday, we will have the discussion on exam. So maybe it will be on 18th October. And your exam will be, I don't know when it will start. Maybe
3rd November.
3rd November. Okay, then you will have so much time. Okay, fine. Okay, so
Okay.
bye bye.
Thanks.